This video is an introduction to ratios, and the first concept we are going to look at is simplifying ratios. A ratio is a comparison. So in this picture below, we have a comparison of how many students there are to each teacher. So let's quickly have a look at how many there are. We have 3, 6, 9, 12, 15, 16, 17 students for every one teacher. That also means that if there were 34 students, that the school will need 2 teachers. 17 over 1 is the simplified ratio, and this is what we're going to look at in the next couple of slides. Simplifying ratios work exactly like simplifying fractions. So here we are comparing 4 to 12, almost like when we had a fraction of 4 over 12. To simplify the fraction of 4 over 12, you would find a number or a common factor that divides into both 4 and 12, which in this case is 4. Dividing both of them by 4 will give me a simplified fraction of 1 over 3. And simplifying a ratio works exactly the same way. We find a number that divides into both the numbers given, which in this case is 4, leaving us with a simplified ratio of 1 to 3. Let's do the same for the next one. Here we're comparing 18 to 6, which we also can write as a fraction of 18 over 6. In this case, the common factor that goes into 18 and 6 is 6. So dividing both these numbers by 6 will give me a simplified fraction of 3 over 1. The same if I do the ratio. I divide both of them by 6, which gives me a simplified ratio of 3 to 1. So understanding the concept of fractions really help understanding ratios. So do you remember that we cannot have decimals in a fraction? The same rule applies to ratios. So if you had a fraction of 23.2 over 92.8, we can't leave this fraction like that. So what you can do is you can multiply both of them by 10. And this will give me a fraction of 232 over 928. Now I know it's very difficult to simplify fractions that have really big numbers in them, but you can start with a small number and just keep on going. So the easiest way is just to start by halving them. So over here, if I halve each of these numbers, I will get 116 at the top, and I will get 400, and let's see what's left over, 128, and half of that would be 64. So 464 at the bottom. Let's halve that again. So half of 116 is 58, and half of 464 is 232. Let's halve that again. That will give us 29 over 116. And when you see 29, which is also a prime number, you know that you cannot simplify the fraction anymore. And now we can go back to our ratio, and we can know that the numerator, which was the top number and the first number in our ratio, was 29. It's simplified to 29. And the denominator, which represented the 92.8, simplified to 116. And that's how simple it is to simplify ratios. We can go through exactly the same process even if there are 3 numbers. In this case, however, we cannot write it as a fraction. We merely need to find the number that divides into all 3 numbers. So here in the first case, 3 goes into all of them, and also 15, which will be a bigger number. So you can always just double check that 15 does indeed go into all of them, because you don't want a decimal as an answer. So 30 divided by 15 will give me an answer of 2. 45 divided by 15 will give me an answer of 3. And 60 divided by 15 will give me an answer of 4. And there's no number that can go into 2, 3, and 4, which means that this is our simplified ratio. In the next example, you might know that 12 goes into all of these numbers. So going through the same process, we're going to see how many times 12 goes into each of these numbers. Into 144, 12 goes in 12 times. Into 12, it goes in once. And into 60, it goes in 5 times. And 12 to 1 to 5 is the simplified ratio. When you are given a situation where the units of the two numbers in your ratio, or three numbers, are not the same, you will have to make them the same unit. So hopefully you know that there are 60 minutes in an hour. If you didn't, there's a little note here for you on the right. So I'm going to make the 6 hours also into minutes. And I do that by multiplying the 6 hours by 60 in order to get it to minutes, and that is 360 minutes. So when I compare ratios, they always need to be in the same unit. So in this case, I'm making everything into minutes. I prefer that to making it into hours because then I will work with a fraction of an hour. And as we said on the previous page, we don't really want to do that. So 360 to 40, we can simplify that to 36 to 4. And once you have that, you can simplify it even further by dividing it by 4 on each side, which will give you 9 to 1. So let's have a look at the second question here. Here we have milliliters and liters. And just for a reminder, I hope that you know that there's 1,000 milliliters in 1 liter. That means that I need to change the liters here to milliliters by multiplying it by 1,000, which will give me 3,000 milliliters compared to 250 milliliters. So if I divide both of them by 250, I will get a simplified ratio of 1 to 12. Let's have a look at an application of a ratio question. In this question over here, they tell us that 2 centimeters on a map represents 100 kilometers in real life. And they want us to determine the number scale on the map. If you've ever looked at a map, you will know that it either has a bar scale at the bottom of the page or it has a number scale. And the number scale says how many times bigger the real life is than the map representation. So just like we've learned in the previous page, we need to make the units the same. And in this case, we have centimeters and kilometers. If you are unsure of how to go straight from kilometers to centimeters, start by changing it to meters. And in order to change it to meters, we are going to multiply by 1,000 because there are 1,000 meters in 1 kilometer. This gives me 100,000 meters, which is the same than 2 centimeters on the map. Now, from meters to centimeters, you might know that I need to multiply by 100. And now we're going to get a lot of zeros. So make sure to count your zeros when you write this down. We had 5 and we're going to add another 2 zeros to that. So that is 7 zeros. And 7 zeros is 10 million. And this is still the same as 2 centimeters on the map. So now in our final step, we get to the point where we need to simplify. And you will see that if I need to go from 2 to 1, I need to divide by 2 on the left-hand side, which means I also need to divide by 2 on the right-hand side. So 10 million divided by 2 will give me a final answer of 5 million. And remember, there's no need to add any units to the answer because a map scale merely tells us how many times bigger it is in real life. So if you measure 1 centimeter on the map, it means it's 5 million centimeters in real life. Also, if you measure 1 millimeters on the map, it means it's 5 million millimeters in real life. And scale is a beautiful application of ratios.